So I'm going to talk about this small house in Hackney. It's not very far from here, just outside the city. It's in a conservation area. I owned the site and decided to build a house, not like a developer. I didn't have a client. I was the client and the architect, if you want. But I was also an architect without a proper brief. So it's a very strange project in terms of process for me, because the brief evolved at the same time as the rest. Planners obviously always come into play, and to cut a long story short, the planners wanted me to do the house half sunken. So a bit like a Victorian house, you have like a lower ground floor and an upper ground floor. Here's the site. The site is on a street that goes north-south. You see the red block is the building. So to the south of the building, I've got a row Victorian building, which is going to be very important in the design of the building. East-west orientation, easy access from the street, a very nice site, very close to London Field. The idea of the project is really best seen in the section, so I'll start with that. It's a low building. The planners wanted a low building. They wanted an object sort of separated between the Victorian house and the other, the Victorian villa that's immediately to the north. And I decided to do a two-story building that I wanted as simple as possible. Living space upstairs and bedroom downstairs. Here you see, this is the garden level, the street, and here's the plan. Simple plan, upper ground floor on to the right, you see it's a single space, and the lower ground floor here with 2 bedrooms, 2 bathrooms, and the way you come into the house from the street is you enter past the garden wall, go down a few steps, and you arrive at the lower level, which is quite unusual. You arrive at the lower level, and you go back up into the living room. My ideas really were typical architects. I wanted to do something that has they're simple and flexible. The simplicity for me was important in terms of space, but also in terms of construction. And from 2002 or 3, I've been really wanting to build something with CLT and the Gutex product. It took me about 10 years to get it done, but I got there in the end. And in terms of space, really, I wanted to create something that had large spaces for a small house. The building is about 9 meters long. So if you imagine the upper floor here, it's a small house, but where do you get a 9 meter by 6 internal space? It's 5.5 by 8.9 or something. It's quite unusual. And downstairs also the bedrooms are quite generous. Overall the house is about 100 square meters for a 2-bedroom house, which is way above the standard. However, I sort of underdeveloped the site in a way because I decided to keep a garden at the back, which is important for, I think, the quality of the building I was providing. So simplicity was really my goal. Sustainability was also very important, and I thought, how do I do that? I tried the code for sustainable homes. I looked at different standards. I was never satisfied, so I decided to look into Passivhaus. And I wanted the building to be very green in terms of energy, in terms of the building, the materials it used. But someone told me, oh no, you can't do a passive house there because you have a Victorian terrace to this house. So you imagine solar gain from the south, non-existent. Then, by chance, I met Peter Ranken, who said, yeah, let's give it a go. I think I can do it. And he's going to now explain how we did. We worked together on this.
I'm Peter Ranken from Accredited Passivhaus Design. Bernard and I first met at EcoBuild, where there was a stand where I was helping the Passivhaus Trust. First of all, I want to just, has everybody heard of Passivhaus? First of all, how many people think they know all about it? Only a few. There's one or two. I know there's at least one other Passivhaus certifier or designer here. This is just a very quick summary. I could spend a whole 40 minutes talking through about all the details of Passivhaus, but I won't. Essentially, it is a way of looking at buildings which everybody thinks it's all about low energy, but actually it's about thermal comfort. It's about having spaces which are at the right temperature, at a consistent temperature that is comfortable, that has been proven by research. And for those of us who live in the typical British house, it means there are very few drafts, There's no coal spots, there's no thermal bridging, there's even surface temperatures. That's why in England we have to have triple glazing. And it's got fresh filtered air being delivered all the time. And it has openable windows. There's a bit of a myth which says in a passive house you can't open the windows, which is not true. All passive houses have openable windows, and very often they are open in the summer. And in any building, if you open the window in the winter, it's going to get cold, so that's the same in a passive house. The minimal energy use is about balancing the internal heat gains and the external heat gains from sunlight to match the heat losses through the fabric, through the roof, the windows, the walls and the floor, to actually get your energy demand down to the lowest practicable level. Not quite to zero, because there will always be a little bit. If you went to zero, actually you'd be spending an absolute fortune, much more than is really conceivable on your insulation and on your surfaces. So it's a really low energy use, and I've given the figures on the slide here. A passive house annual heating demand is 15 kilowatt hours per square metre per annum, and that's based on the German standard of usable floor area, which is slightly less than the gross internal floor area, GIFA, which is how we tend to measure buildings in Britain. The average British house is 171 kilowatt hours per square metre, so a passive house uses a tenth or an 11th of the amount of energy to heat compared to your average British house. A building regs house will be around about 45-50, maybe a little bit less if you're applying the fabric energy efficiency standards. That's sort of the technical bits. The diagram on the right is a explanation. Sunlight coming in through the windows, triple glazed windows. You don't have to have solar thermal panels, but there's two additional classes of passive house called Passive House Plus and Passive House Premium, where you use, once you've built your passive house, you can meet your energy demands using solar panels, usually PV, or you can exceed it, and that's Passive House Premium. And then you've got a ventilation system with heat recovery. This is actually a slightly old diagram we've got now, because it shows the ventilation unit up in the loft. Actually, we tend to try and put it down either in the kitchen or somewhere where you can get at it to change the filters, because we found that if you stick it up in the loft, people forget about it and then the filters get clogged. So the last part of Passive House is a quality assurance process, whereby during the design of the building you have the input of a certified passive house designer, like myself. I happen to be an architect as well, but there are others who are consultants who have different previous qualifications. And I will run through the design using the Passive House planning package, which is a very big Excel spreadsheet, inputting all the data for the building components, climate, the window sizes, the heat loss areas into the design. That is then checked by a third-party Passive House certifier, who checks my work, checks the drawings, checks it's all right, before construction. Then during construction, the contractor has to monitor very carefully that the construction drawings are followed, and there's photographs to show that all the insulation has gone in with no gaps. There's an air test, which is 0.6 air changes per hour. Building regs, a slightly different metric, but the number is the same, is about 10, so it's very, very airtight compared to what British building regs requires. Once that's all been achieved and there's a log of photographs, that's sent back to the certifier, who then sends it to Germany. Germany checks it, and then you can call your building a passive house and you can screw the plaque to the wall and be very proud. The quality assurance is there to check that it's been built properly and it's been designed properly. And that process means there's actually a very small gap between achieved performance and designed performance. So we've heard of the performance gap in terms of buildings using SAP as their primary energy design tool, which actually it isn't, it's a compliance tool. Passive House doesn't get that. That's just a quick run through. Coming to Bernard's house, I'm going to go into a few more details here, but essentially it's a very simply constructed building. The lower ground floor is concrete, which you can see there, which has got a slab above a raft foundation, which is insulated, so there's 300 millimetres of polystyrene underneath the raft. Concrete walls internally, and they are also the finish inside, except for one wall, which I might talk about later. And then upstairs is the cross-laminated timber box, which provides the floor, the walls, and the roof. One of the reasons why I was optimistic about the house was that it has, in Passivhaus terminology, has a good form factor. So it has a relatively small heat loss area to what's called the treated floor area, which is the floor area, because the key metric is kilowatt hours per square metre. So it's got a form factor of 0.258. So the heat loss surface is roughly 4 times the floor area. But we had a big problem, which Bernard has alluded to, which is that one of the major heat sources for a passive house is sunlight, and this site doesn't get sunlight from the south. Although we did discover, when there was a visit that Bernard, we were showing a developer around last summer, and we discovered that on the 21st of June, the window in the bathroom on the lower ground floor at midday gets about 3 inches of sunlight. So what that meant we had to do was that we had to maximise the insulation of the building. And the figures that we achieved there, most of them, or half of them, have 0.0 something as a U value, because there's a lot of it. So there's 300 millimetres of polystyrene in the ground. There is 250 to 300 millimetres of insulation on the lower ground floor, wrapping round the concrete walls, and then 320 millimetres of Gutex on the walls, and then in our I whisper it, a little bit of Kingspan on the roof, below the single ply membrane. The front door has a U value of 0.6. It is extremely difficult to get doors to perform to a very high U value. And in fact, one of the manufacturers who does Passivhaus windows does a very well performing door, but actually it's a window, and they just put aluminium cladding on both sides, and you can't drill through to put your door numbers on because there's actually glass behind the metal bits. So the door is 0.6.
In our case, it's north facing that door, so it was actually a crucial.
It's really important. Building services are very simple. We've talked about the ventilation system, and the reason why you need one in a passive house is because we need fresh air all the time, and in your typical leaky Victorian house, a lot of that comes through the floorboards between the sash windows, through leaky construction. And once you've sealed all that up, you still need fresh air to breathe, and therefore that's supplied by a continuously running ventilation system. That has to have heat recovery in it, otherwise you're basically heating the air up and you're blowing it straight out. And you're still blowing the air out, but we're recovering the heat to pre-warm the air that comes in. And that's an essential component for a passive house, and it's the only one which, as a passive house designer, I would insist is a passive house certified unit. So there are lots of manufacturers who say, yes, we've got certified insulation and certified windows, but actually you don't have to use those as long as you've got the technical data. So that's a German ventilation system by a company called Paul, and the drawings at the bottom, which just shows the ductwork routes. So it's all concentrated in this corner upstairs in the kitchen of the unit, and that's the photograph. That's how big it is. So that's a 900 wide cupboard, and it's filled with ducts and ventilation walls. And then there's a series of supply pipes in blue and extract in green, I think, at the bottom, just threading its way through the building. One of the beauties for me about this building as a passive house is actually you can see how it works. You can see where the ductwork is, and that's a function of the architecture. The outputs from the passive house calculations is that we've got a space heating demand of 14 kilowatt hours per square metre per year, with a heating load of 9 watts per square metre. So 9 watts per square metre, and we've got about 100 square metres of floor area. That's 1,000 watts is the power of the heating system that you need within the house. An electric kettle is about 2,000 watts. So you need very, very small power. So the heating system for the house is towel rails in the bathrooms and a small electric heater in the living room. Hot water is from a gas boiler, We tried very hard to do it all electric, but we couldn't quite do that. Partly because the shadows for the solar panels, so we couldn't have a solar panel and an immersion heater on the roof. The air tightness, at the design stage, I'm always very cautious. So the limit is 0.6. Actually, in PHPP, it rounds it slightly, so you can put it in as 0.64. Our first air test was 0.37, which stunned everybody because we thought actually it would fail, but actually it was really good. Final one was 0.29 air changes per hour, which is pretty good. And that's the verification sheet for the output page from PHPP for the performance that we've got. As an architect, as well as a passive house designer, I was in a slightly difficult position because I was helping Bernard, a fellow architect, to design his own house. And I had to make some sensitive conversations because some changes were needed during the design process. And this affected certain elements of the building. The original thinking was that we would have a combined heating system and a ventilation system, whereby you've got a small heater within the equipment known as a Genvex unit. That actually wasn't efficient enough in terms of its heat recovery that came through, even though it's a simple package that is used in a lot of properties, particularly in Germany. So we had to then separate that out. So that meant there was a bit more kit. We had to have separate heating and ventilation. We had to add the insulation, which I've talked about. The difficult bit for me was to actually say to Bernard, actually, we've got to remove some windows, because there is a very nice flowering camellia, and on the original design there was a window just in front of it, so you could sit in the living room and look out at this lovely plant. Unfortunately, that window faced north, and we couldn't, it was generating too much heat loss, even though we'd maxed it out on the insulation everywhere else. We changed the windows, we got rid of some of the windows. I then had to do something counterintuitive on the window glass specification, because I thought, right, okay, we need to insulate as much as possible, therefore we have to have windows with a very low U value and what's called a low G value, because they run in tandem, which is the amount of heat that comes through the windows as well as the heat that is lost through them. And I found that actually the only way we could get it to work was to actually make the living room windows that faced west and receive the sun less insulating, to make them what's called a solar plus windows, to actually increase the heat that those windows generated. And that tipped us over, along with putting in the U value of the soil below the building into PHPP. So we were having to delve into very remote recesses of PHPP to get the whole house to work. These are a summary of the construction details, so I'll now hand over to Bernard.
So you see on the left-hand side the CLT and wood fibre insulation. There's a ventilated cavity for the zinc skin, and the lower ground floor is done straight on the concrete. The red line is actually where the building is very simple. From the foundations, where I used this foundation system, up to the top, it's a straight line. VCL, so you can inspect it, you can see it. Actually, my kids are probably the best at describing how the building was built, because it's like an onion. It's one layer at a time. And I will take you through the construction sequence from the very beginning, digging to the end in a minute. And I think if you keep that in mind, you'll understand why I insist so much on the simplicity. Because when you think of it, I was there as client, an architect. My luck was to have got somebody to talk about the building. He says, it was tough. No, it was great for me. Somebody to tell you, Bernard, maybe having some walls in a bedroom is a good idea. Well, it's refreshing. It's good. So yes, I eliminate this window with pleasure. And why didn't I think of that earlier? Well, great. Now I'll take you through the sequence, and it's a bit unusual because a passive house requires a lot of attention on detail. So you need great scrutiny. I tried to find contractors, but I didn't. I decided to start building because I realized that in my schedule of and description of the work, I had isolated trades and managed to get them lined up, if you want. And I realized, well, maybe I can start. Maybe I can do the excavation, the drainage, the insulation, the concrete. And then, oh, Urban is going to come and do my CLT. So they did it. And then, oh, my window, I've ordered them already. They can come. Oh, I've got Tectonics will have come earlier. And I realized gradually that I was passing the center of gravity of the building, and the building was up, and I didn't need a contractor. And I'm not a DIY man, I promise you. I'm not the hands-on. I was just trying to build a house, and I couldn't find a contractor who would. I don't know, I think they got scared because I was living next door. I didn't tell you that, but the plot is actually attached to my garden. And maybe client, architect, contractor, there is a fear there that I think we needed to eliminate. And I had the success of the project for me was the team I had around me, which is not a team in a conventional sense, but I think from APD to Urban to Ecological building system, you know, if the insulation stands up, it's because of Niall and Paul. And now I think you will understand why. I do anyway. And the HR design, yes, I found people who were competent at explaining how to do it and actually focus on the building. And that's probably the biggest lesson for me was concentrate on the detail. So I'll go now through a few slides of the construction. These photographs actually taken from the staircase of my house. I could see the site very well. Bottom right, you have the excavation. We had to build the retaining wall along the road. Interesting thing of the project is this product. It was the foundation system. I don't have concrete straight into the ground. We have excavation and a bed of insulation. And it's a company called Accredited that supplies this in the UK. The interesting thing is the geometry of the building was then defined by the insulation, which was pre-cut from our computer drawings. For me, it was fantastic. It means that the setting out of the building, and the building is not square, so it's a difficult exercise, was done at that stage in a factory. And I thought, oh, this is actually something really good. This is the waterproofing layer that goes on top of the isoquick, and rebars. Because obviously we're against the street there at the end, I brought the waterproofing all the way up the wall. You see a second wall being built for the house. You might remember, you'll see it again, but the concrete shell is like a bath, if you want, and this is what's being built. This is a very exciting day, 23rd of June, 2 years ago. I saw the Austrian driver pass in front of my house with this and go in the wrong direction. I said, where's my house going? And then he found his way, and here it goes. And it took 2 days to install the building. So I think it's only 12 tons of timber. I think my neighbors had left for the week, and when they came back, the house was up. Here's the panels. We talked about the fact that the site was very small. So most of the panels were hoisted over the site into the garden. Small panels were erected first inside the concrete lower ground floor, and then here you can see the bigger panels being hoisted by the crane. This is one of the walls of the lower ground floor, and this is one of the floor plates. This floor here was done in about half an hour. It's marvelously silent. It's incredible to see these flying pieces of CLT, but I'm sure you're familiar with that. I asked Urban to supply panels with some of them with a better finish than others. Because the building was for me, I didn't really have any, I decided to eliminate all the finishes. I said, really, I didn't have the money for it. To be honest, the first thing was, how can I do it simply? Let's expose the construction, which is what the architects like to do. But I asked for a higher grade of finish for most of the panels, which you can ask for. The other key thing that I did, and the luxury was I was next door, and it's a small site, so I see all the advantages I had, but I was obsessed with the weather. The building never got a drop of rain on it. That's before the Urban came, I had a roof over my concrete. So the site was completely covered. We took the roof off, installed the CLT. I remember one day I saw the rain coming. I went to buy tarpaulin and I covered the top So that day it was quite. Then we quickly came to put the DA membrane on the building so the CLT stayed dry. And I covered the building scaffolding again afterwards. And for the rest of the construction, it was dry till we finished the zinc work. You see the box is really finished. I was teased that I made a model of this, a big model, a 1:30, and it took us 3 days to build the model, but 2 days for it to work. This was a very beautiful moment of the building where in here you see the spirit of what I wanted to do. You see the shell, you see the structure, and it really felt already like a building at the time. This is a key stage, obviously, and here I got advice from Ecological building system to get in touch with someone called Roman Shipura, who's a German living in Ireland and specializes in installation of their product. And it's probably the best decision I made. He came in July, watched Germany play football in the evening, and worked with his assistant to wrap the building up like a Christmas present. Super competent. I didn't know much about the products. It was absolutely key to have him. He was excited about the project. He understood straight away the logic of it. They brought the DA membrane, the tapes. They knew how to do these details. They knew how to the windows afterwards. But here they go, cutting absolutely perfectly, systematically, wrapping up the building. It took them 2-3 days already, and it was a really fantastic job they did. I wanted Roman to install the text as well. The time slipped a little bit because I didn't have a contractor, so I was looking for trades one by one. I decided to wait for Roman, but when he was free, and all the installation of Qtex you will see afterwards was done in January for two weeks. I could order the windows ahead of time because it's cut in the CLT, so it's going to be accurate. And the concrete was accurate because I was like a Rottweiler on site, making sure that's correct. It is terrible, but the luck I had was to be living next door. Because it's unbelievable how much you think people will follow the measurements. It's better to go and check. And it's quite sad, but I had to do a lot of that. I did it with pleasure, but it's not always possible. So I ordered the windows, the window got installed, got taped, and I thought, well, great, this is the time to do the first air leakage test. And Paul Jennings came to, who's quite well known, I think, in the Passivhaus world, came to do the first air test, and it was amazing because the result was 0.37, which was much better than expected. And it's probably due to the DA membrane and the careful attention that Roman had put into it. The junction between the concrete base and the CLT obviously needed attention as well, because they put the CLT on shims, so you needed that, and the load needs to be spread evenly, so it had to be filled with appropriate mold.
You may see that this photograph here shows the DA membrane billowing during the air test, just proving that air somehow does get through. But we are at 50 pascals at that point. It's a testament to the work of Roman that actually we got that sort of that quality of air test result at the first test, because most buildings tested for the first time fail unless they're a very experienced team of contractors are involved.
So the key stage after that was the installation of the insulation around the building and all the penetration with all the grommets, etc. And Roman and his team came just as a joke. The Kingspan has been relegated into a work surface rather than insulation for the building. For some reason on this project, I can't remember who advised me that, but I was told don't put Gutex on the roof. Just use Kingspan. There is too much risk of condensation. You feel quite sad when you see Kingspan turning up and you've done the whole building in Gutex. In the end, it was probably the right decision. You see here, you recognize all the slides you've seen during the day. This is exactly how it was done. But the key here was not my specification. The key here was the skills of the person installing it. They were precise. They knew where to use the primer. They knew which tape to use. I was very happily coming around the site photographing it or talking to Roman about how great it will be. This is Roman at work, putting the 45-degree screws that we've been talking about this afternoon. This is a diagram that was prepared by Paul and Niall before construction. So we have 140, 120 and 60 mil of Gutex products. And it's all, the baton is key, I think, to get this whole thing holding. And we just install these 500 millimeter screws. After that, we just wrap the building in ply with to create the ventilated cavity. And then that was done by, again, a separate carpenter. And then the zinc cladding was installed. Interestingly enough, it's an area full of brick buildings, but the council was happy to have a different material. Actually, I did a proposal for brick, and they thought it was too dull, so I said, okay, I'll do. And once I decided to, it was clear that I could do something that was not, I was delighted because wrapping brick around CLT is something I was not really happy to do, and having done it in zinc, and this is zinc, the product, I was quite happy with it. I'll show you some pictures of the inside. So this is the entrance hall, where I left all the CLT exposed. Downstairs is concrete, and I have a concrete screen. There's a bit of insulation, extra insulation underneath the screen itself. And you see here the NVHR, light conduits and lighting. You see this detail here is where the floor slab intersects the wall. It's between it's at the front of the building, between the building and the street. There is a low roof here. And it's not hyper regular, but I love that. I just thought I'm going to leave that visible. What I did is just put a UV, just a slightly white wax on it afterwards. So this is the lower ground floor. My parents-in-law moved into the house after it was finished, and I'm not sure about the picture with the furniture, all the artwork, etc. is there. It's there. So here you see I chose a flooring, so the floor is obviously not the CLT. There's an acoustic layer between the finish and the structure. But you see the window, the door with the big windows, triple glazed, and that's the kitchen. Kitchen here, the MVHR is that cupboard there, and you see here the supply duct for the MVHR. This is the space used, 5.5 meters wide and 8 point something meters long, so it's one big living space. What's quite unusual architecturally, if you want, it's a big room that doesn't have a door because you come in from below. So it is actually quite nice. I chamfered the building for two reasons. One was on the street side, I wanted to break the volume because it sits between building and it makes it smaller, it breaks the scale of it. But also by chamfering on the other side, I created a space that feels more like a room. So it feels extremely peaceful, first because of the wood, I think the material is very important, but also because of the shape of it. What's quite interesting architecturally for me too is that it's a large space in a small building, but what makes it work is what we call in the architectural language the scale. When you see the scale of the CLT panels, which are nearly 2 meters, still the windows are 1.1 meter. It's the biggest window in Ranken made that's tilt and turn, and I've got very wide floorboards. Everything is big, yet the house is small, and actually it works very well in terms of scale. This is why I organized the house the way it is. You're in the living room on the upper ground floor, and you look at other people's garden, not really the garden, but you have distant views of gardens, and you might be in Hackney, but I tell you what, the house is airtight, you don't hear the traffic, you see trees, it's very, very green. And it was welcome here. These are pictures of the cladding at the rear. Thank you very much.
Thank you.